Today I'm presenting here UAV or drones and their real-time applications. And now we will see the table of contents. Here we will go firstly like introduction, types of drones, flight planning, types of surveys, how we will do image processing, and how to prepare a cadastre map and their flowchart and their applications. And after getting the data, how to publish and make web application or mobile application, all those things. Initially, first, the drone is a unmanned aircraft system. It not necessary to operate by any person, and it can be operate with the help of remotely and also without any remotely. Like it can be operate like in 3 ways, we can say, like automatic, manual, and follow mode. Mostly the automatic mode will be used for planning the 3D data or acquiring the ground data. And there are 4 types of drones present in our industry, like multi-rotor drones, fixed-wing drones, single-rotor helicopter, and fixed-wing with hybrid VTOL. In that, see, in multi-rotor drone mostly used, there are categories. Like here we can see the nano drone, which is less than 250 grams, micro drone, which is like 250 grams to 2 kg, small drone 2 to 25 kg, medium 25 to 150 kg, and above 150 is called as larger drone. Here in our industry for acquiring like remote sensing and GIS applications, we will use small drone, which is approximately 2 to 5 kg. And here, first of all, what we will do is before starting flight planning, we have to do elevation analysis. Because our ground is not entirely flat, so we have to find out what elevations are there in our surveyed area. Depending on that elevation analysis, we need to plan the flight planning. I will show a glimpse of about how the, see, if you see here, this is the elevation feet is there. If you move in anywhere, the elevation is changing. So we have to analyze the entire elevation of the area. After that, and above that, we have to plan like 60 meter or 70 meter height for flight planning. So I will just demonstrate how we will do flight planning. Like this is the drone deploy website is there. In this, we can make a project. Like I'm choosing Hyderabad area and create project. And here there are 2 types. We can make the planning here, or otherwise, if you have any like vector data like shape file or KML file, we can import that one so that it will come accordingly. Here just I'm planning here. So for example, I want to take the data of this ground. Okay, so I'm planning like this, and needed you can move this boundary also. See here I have like 60 meter height. So the height will depend the resolution, because if you go for 60 meter height, it will give 1.4 centimeter per pixel. If you change, automatically the resolution will be changing. Okay, so accordingly we will go for the respective height. Okay, after going this, here we will go for advanced setting also. In advanced setting, if the low light is, the project has to be stopped, and here what type of drone we are having, it will be displayed. Like it is like a small drone or heavy drone, large drone, whatever the drone is there, it will be displaying here. Okay, and it will also shows that how many minutes it will take to complete this entire boundary, and how many hectare area it is covering, how many images we will get, and the usage of battery also. So for simply, we can, if you want like in a specific boundary, here we can give like import KML or shape file, so that our specific boundary we can view, and we can take the data accordingly. See, if you test the simulator here. Here we will do pre-flight check, and here all permissions are gone. We got means permission means before we fly some DGCA rules. Like first of all, no permission, no fly. This is the first rule. First of all, we have to take the permission with the nearest airports. If it is an international airport, there will be a boundary buffer of 3 kilometers, national bound buffer of 1 kilometer from the airport. We have to fly, so that we have to take permissions accordingly, and then we need to plan the flying part accordingly. See, if you click start, it automatically demonstrate how the drone is flying and how this image is taking the how the data is taking each part of images will be acquired initially. Like this, it will be getting the data. So after taking the data, we will get these type of images. Entire one scene we will be getting like 206 images we have got. After getting this data, we will process. Okay, this is the part of flight planning, and we will keep like 60 meters because it will give the high accuracy like 1.4 or 2 centimeters per pixel, because the main aim of getting the drone data is resolution high. So this can be done, as I said, like drone deploy or Pix4D software. And for flight planning, after planning, we will have to estimate how many drones can give how much area and what is the estimated time. So if we are going for one drone to collect the data, it will take approximately 15 minutes and it will cover about 1.5 area. Similarly, if we are going more 10 drones, it will take 15 hectare area like this. Similarly, the manpower required will be there. There should be one pilot. The pilot should have DGCA license, and there should be a co-pilot and observer, because the observer should be present like 500 meters away from the flying location, because after 500 meters we can't see the drone properly. So there should be an observer, and he can immediately he can give messages like the drone is in empty area, any are there, any obstacles are there, that he can be giving the information. So while taking the flight planning, there should be some overlapping should present. There will be two overlappings, like one is front overlap, second is lateral or end overlap. See, because we shouldn't there should not miss any kind of data while we are taking. So the overlapping plays a major important role to avoid the loss of data. If, for example, if this is the in 6th image, we are taking this data, but in 6th image, this data is somewhat redundant. So it will be present in 5th image also. So if anything is missing, we can take the image, we can take the data from another images, because it will be having the overlap. So there would be no missing data. So the percentage overlap should be maintained as usually. Here also we will keep percentages. Overlapping percentage will be there here. We can keep here. So, okay, after connecting the drone, it will give the percentages also, overlapping percentage. Okay. Next is DGPS survey. DGPS survey, the use of DGPS is it will give the constant and accurate latitude, longitude, and elevation values, so that there are some drones will be operate with the help of PPK and RTK, real-time kinematics and post-processing kinematics. If you are having the drone like RTK drone, then we have to integrate the DGPS data also, because we can have accurate values, and with the help of this data, we can go like some major applications like watershed management, sewerage operations. For this type of planning, we should require very accurate information. So here in DGPS, we will be having one base station and one and two rovers. So this will be operated by DGPS master, which is a base station. One person he will be operating, and another two persons will be operating rover one. Rover one will be operating one person, and rover two will be operating the second person. Here the main important thing is whenever the DGPS has connected with 4 satellites, at that time only we have to take the data, because each one satellite we will estimate like one is giving like latitude, longitude, time, and elevation. So if we are having more satellites, the accurate automatically increases. So DGPS data plays very important role in drone surveying. And the next one is GPR survey. GPR survey mainly used for the whatever the cables or lines present underneath the ground. So while mapping like utility mapping or gas links, making maps, the important thing is we have to visualize how the structure of cables are present beneath the earth. So we will, while presenting a good base map, if we are having utility cables also in the map, so we can have complete structure of the city or structure of the village. So accordingly, we can plan the sewerage operation or watershed planning or reservoir planning, all those things. So here we can get water network, sewerage network, power network, drainage, telecom network. These type of cables we can get with the help of GPR survey. So after getting all the data from the drone, we have to process with the help of any software like Pixel 4D Mapper, IGSoft Metashape, Drone Deploy, or Global Mapper, because we will be getting the images in chunks. So for maybe there will be, if you are planning for larger area, you will be getting like more than 1,000, 10,000 images also. So for all those images, you have to process and make a single ortho-rectified image. Okay, with the help of ortho-rectified image, we can plan the mapping, asset mapping, all those things. Other than ortho-rectified image, we will get like digital elevation model, digital surface model, digital terrain model, and contours and point cloud data. So with the help of these data, we can do multiple analysis according to our requirement. So first of all, for processing this software, we need the system requirements like Windows 10 operating system, and it should have Intel Core i7 processor, and it should have like GPU also, because while processing the data, the CPU will consume 100% data. So if it is GPU, it will support for after processing 100% CPU also, GPU will support the processing speed. So definitely for this type of processing softwares, the system should have very high configuration, and the RAM also should be above 64 GB. So mostly these type of processes will be done in virtual machines or VMwares or cloud-based applications. So see here, we will be getting, as I said, there will be 5 types of data like point cloud data, contours, orthomosaic, and 3D model, DEM, and DSM. So I will show the example here. See, as I said, this is the first image which you are viewing is, that is a ortho-rectified image. If you zoom and see the resolution of this image to pixel level, see here, if you calculate this pixel level, see 1.5 or 1.4 centimeter it is coming, because as I previously told that we have flown the drone. If you are flying the drone 60 meter elevation altitude, 60 meter altitude, we will be getting 1.4 centimeter per pixel. So here accordingly we got that resolution. And if you see how clear the data is, if you compare to satellite image and drone image, the data see in the we can see the clearly the names also, like Pasighat Smart City. This is the my previous company area. This is one of my client, and here we have done the survey and we have captured the data. So similarly, we will be having like DSM. DSM is digital surface model. It will give whatever the surfaces present, like trees, buildings, poles, whatever the surfaces present, it will see here. Here trees, buildings are there. It is having only building and trees. This is called as a surface model. If you go for DTM, terrain model, means after removing the surfaces, whatever the plain terrain is there, flat terrain, it will give that model. So these DTM and DSM will help to get the DEM, digital elevation model. There is a like formula like DSM plus DTM equal to DEM. So we will get the digital elevation model. With the help of model, we can estimate the we can do the projects for watersheds and sewerage operations and other like tax management, household information, all those things we can plan accordingly. Okay. After this, we will prepare a base map. Okay. Here, as I said, there will be a 3 to 5 centimeter resolution, and the outputs will be TIFF, JPEG, GEO, TIFF, and PNG formats. And these type of processing after we can perform in RGS. As I told, this is the RGS software. This is the RGS software. Similarly, in RGS and UGS, ADAS imaging, there are many softwares will like licensed and open source softwares. We can choose any of the software according to our requirement, and we can work on that. And after that, we have to prepare a base map. That is the main criteria. This base map, what is base map is, it will be having all the layers present on at that area, means road layer, land use layer, boundaries. If you are having like education departments or administrative departments, okay, all these type of layers will be present. I will show you one example here. If you see here there are all layers are there. See how parks are present, okay, transportation layer is also present, and facilities like schools, hospitals, facility also present. Environmental like geology layer, watershed layer, soil layer, okay, and administrative like what is the boundary, counties, zip codes, and parcels, tracks. All these type of layers are present, and after adding this complete layer, this we can call as a base map. With the help of base map, if we are having readily base map, you can get any data like very easily, and you can do the analysis as per requirement. For example, if you want to plot like how many schools are near to like your restrooms, or how many schools are near to the parks, like this network analysis we can do with the help of this data. This is the base map, like simple image here, and cadastral map.